part D, can we do part D? A series LCR circuit has a resonance frequency of 1460 Hz. When set to another higher frequency, the series has a capacitive reactance of 5 ohms and an inductive reactance of 28 ohms. Calculate values of inductance and capacitance. So we've got LCR. Obviously, it doesn't matter the order we put these in. There's our circuit, resonant frequency of 1460 Hz. So that means that resonance VL and VC are equal. So that's telling us that omega L equals 1 over omega C. When set to another higher frequency, the circuit has a capacitive reactance of 5 ohms and an inductive reactance of 28 ohms, and then calculate the values of the inductance and capacitor. So I think this is so we know that, again, our expression for resonance, that'll tell us that F equals 1 over 2 pi root L over C, and that is 1460 Hz. That's one equation. We don't know L and C. Set to another higher frequency, circuit has a capacitive reactance of 5 ohms. So set to another frequency, we'll call that, so omega is 2 pi f, so 2 pi f h for a higher frequency times C equals 5 ohms. And we also know that 2 pi fh, that's omega L, that high frequency is 28 ohms. Calculate the values of inductance and capacitance. We don't know FH, that's an unknown, C's an unknown, L's an unknown. We've got 3 unknowns and we've got 3 equations. So that should be solvable. If we can eliminate FH, that would be good. So if we multiply these 2 equations together, then these will cancel. I'm going to go up here now. Sorry for the mess. So we've got 2 pi FHL over 2 pi FHC. And multiplying them together, 28 ohms times 5 ohms. So that gets rid of my unknown FH. So I've got L over C equals 140 ohms squared. And here's my second equation. We also know that 1 over 2 pi root L over C equals 1460 Hertz. So I want to solve for L and C. I square that one, and then I can multiply these 2 together, and that will get rid of L. So if I square that, I've got 1 over 4 pi squared LC equals 1460 Hertz. All squared. Then this one times that one. So if I call that equation 4, then equation 5, then 4 times 5, and I'm getting rid of L then, tells me that, so we've got L over C times 1 over 4 pi squared L over C equals 140 ohms squared times 1460 hertz, all squared. So my L's go, so I've got 1 over 4 pi squared c squared equals that value there. Reciprocal square root, so I'm going to get then 2 pi c equals 1 over, square root's going to knock those off, 140 ohms times 1460 hertz. C is 1 over 2 pi that. What does that come to? So 140 times 1460 equals times 2 times pi equals, hit the reciprocal button, 7.73 times 10 to the minus 7. And then L, I can get, may as well use that equation for L. So L equals from 4, 140 ohms all squared times, I messed that up, haven't I? I've done the square already. It's not that, it's that. 140 ohms squared, so there's no brackets there. Yoink, yoink. So I have a square root of 140 there. Anyway, you'll work them out. Not a great question, that one. But that was my thinking. Anyway, hopefully the next question will be a bit easier.